Hey everyone, today we're going to decode two of the most powerful metrics in business, Z-scores and Process Sigma. We're going to get you from guessing about performance to actually quantifying it with, real statistical certainty. This is how you pinpoint problems, spot opportunities, and make decisions that actually move the needle. So, let's start with the big one. This is the question that every leader, every manager has to ask. Is your process really good enough? I don't care if you're running a factory, a call center, or a software team. You have to know if you're hitting the mark. Are you delivering what your customers expect? And more importantly, how do you prove it with data, not just a gut feeling? And that's really the difference, isn't it? On the left, you've got guesswork. It feels okay, it's comfortable, but you can't really do anything with it. On the right, you've got precision, you've got control. This is the language of smart decisions, targeted improvements, and predictable results. Today, we're going to build the bridge that gets you from the left side to the right. So here's our game plan. It's pretty straightforward. First, we'll talk about the real enemy, variation. Then we'll introduce the Z-score, which is our universal measurement tool. After that, we'll level up to Process Sigma to see how the whole system is doing. Then we'll get into what these numbers actually mean for your business. And finally, we'll roll up our sleeves and walk through a real-world calculation you can start using right away. Okay, let's dive in. The number one threat to quality, it's not always some big, catastrophic failure. Nope, it's the quiet, constant, and super costly enemy of inconsistency. You see, every single process has some natural variation. Our job is to understand it, measure it, and ultimately get it under control. And this quote from Ted Hessing just nails it. It gets right to the heart of the matter. If you don't have a statistical way to know your probability of success, you're basically just gambling. You're hoping you hit the target, but you have no real confidence. And that's a tough spot for any business to be in. Think about it like this. Your customer has expectations, right? Those are your specification limits. For example, maybe a part you make has to be between 5.0 and 5.5 centimeters. Anything outside that window is a defect, period. The customer sets the goalposts. Our job is to make sure our process consistently kicks the ball right between them. The more variation we have, the more likely we are to miss. Okay, so that brings up a really big challenge. How in the world do you compare performance between, say, a manufacturing line and a customer service team? How do you know which one is in more trouble? To do that, you need a common currency. You need a universal language for performance. And that solution is the Z-score. I want you to think of it as a universal translator. It takes any piece of data from any process, and it tells you exactly how weird or surprising it is. It measures the distance from the average in a unit called a standard deviation, which is just a fancy way of saying a normal amount of variation. So a high Z-score just means, whoa, that was a really unusual result. Let's make this real. Look at these two totally different problems. Process A is a physical measurement, right? Process B is just a count of complaints. Right now, they're apples and oranges. Is a 0.5 centimeter miss a big deal? I don't know, maybe. Are 45 complaints a disaster? Could be, or it could be a fantastic month. We just don't have the context. So I'm asking you, based on this alone, which manager should be sweating more? It's impossible to tell, right? You're missing that key piece of context. What's normal for each of these processes? And boom. This is where the Z-score provides instant clarity. Once we do the math, we see the widget's deviation is only 1.5 standard deviations away from its average. Not great, but maybe not a 5-alarm fire. But those 45 complaints, that's a Z-score of 2.8. That is a highly unusual event. And it tells us that process B is where the real problem is. Just like that, we know exactly where to focus our attention. Okay, so we've just seen how to evaluate a single data point. But to run a business, we need to understand the capability of the entire process. We have to zoom out from one event and look at the performance of the whole system. And this is where we make the jump from Z-score to Process Sigma. Now, the star of this show is the famous bell curve. This shape is what we call the voice of your process. It's literally showing you what your process naturally does. The peak is your average, and how wide the curve is shows your variation. A tall, skinny curve, that's a consistent process. A short, wide one, well, that one's all over the place. Now, let's bring in the voice of the customer. Remember our goalposts? These are your specification limits. These are the non-negotiable lines that define what's acceptable. And the whole game of quality management is just making sure the voice of your process fits nice and comfortably inside the voice of your customer. And that brings us to Process Sigma.
It's a really simple but powerful idea. It literally just asks, how many of your standard deviations, your units of variation, can you fit between your average and the closest goalpost? The more sigmas you can fit, the bigger your safety margin. It means your process is way more capable of keeping your customers happy.
So saying you have a 4 sigma process is cool, but it's still kind of abstract. To get people to take action, we have to translate that number into a language everyone in the business gets, and that language is defects. We use a metric called defects per million opportunities, or DPMO. What's just incredible here is how quickly things improve. Look at the jump from 2 sigma to 3 sigma. You go from almost a third of your output being junk to less than 7% defective. But then the jumps get even crazier. At 4 sigma, you're looking at about 6,200 defects per million. By the time you get to 6 sigma, you're down to just 3.4. Now, it's really important to note that this famous 6 sigma number includes a 1.5 sigma shift, which is an industry standard way to account for natural drift over time. It's a key detail to remember. And this visual, man, it just makes the difference crystal clear. A 3 sigma process with a 93% yield? That sounds okay, right? But it actually means almost 67,000 unhappy customers or scrapped parts for every million you make. A 6 sigma process is playing a completely different sport. That bar on the right is so tiny you can barely even see it. And that, my friends, is the difference between an average company and a truly world-class one. Okay, theory is awesome, but the value is in the application. So let's walk through a real-world example using customer complaint data. This is exactly the kind of messy, real-world data you're going to have to deal with. The key here is just to follow a clear, repeatable method. So first things first, we have to standardize the data. We can't just compare raw complaint numbers because what if we sold way more stuff one month? So step 1, calculate a rate. Once you have your monthly rates, you just calculate the average and the standard deviation. And finally, you plug each month into the Z-score formula to see how it stacks up. And here are the results. Now, months 1 and 3, they're pretty boring, right? Z-score is less than 1. That's just normal process noise. But look at month 2. With a Z-score of negative 1.13, its complaint rate was significantly lower than average. This isn't a problem to fix. This is a huge opportunity to learn. What did we do right in month 2? Can we do it again? The Z-score didn't solve the problem, but it put a giant flashing arrow on exactly where we need to look to find some gold. And this is a final and honestly a vital piece of wisdom from Alex Johnston. The math is universal, but corporate cultures are not. You should always confirm the local definitions. Does your company use that 1.5 sigma shift we talked about? Are you looking at defects on one side or both sides? Asking these kinds of questions shows you know what you're doing, and it makes sure your analysis is actually useful. So, there you have it. We've gone from vague guesswork to precise knowledge. We've given you a universal translator to compare any process in your business. So the only question left is, where are you going to use it first? What part of your organization is just waiting for this kind of clarity? Because finding that, that's your first step to making a real, measurable impact.